Hi everybody, this is going to be our fourth video for Unit 8, and today we're going to talk about something called complex fractions, where it's going to be a fraction, and what's in the numerator of this fraction is a fraction, and in the denominator is a fraction. So it's very confusing, it looks very complicated, it's really not as bad as it looks, I promise. The first thing that we always want to make sure of is that we have a single fraction in the numerator and a single fraction in the denominator of this entire fraction that we're talking about. If not, we're going to have to, do some combining, probably find some like terms to make that happen. And then what we want to do is we want to rewrite this massive fraction as the division of two fractions. And then we know that instead of dividing, we can really just multiply by the reciprocal and then simplify as we've been doing. So this is what I mean by a fraction divided by a fraction kind of situation. The important part here is that you recognize that this is the fraction bar of the bigger fraction. So this would be our numerator, this would be our denominator. So they're single fractions in the numerator and denominator. The first thing we want to do now is we want to rewrite this so that it's not as messy. Let's rewrite this so it's really a divided by 2 divided by a squared divided by 4. And then we can change it to a over 2 times 4 over a squared. And then we can do some simplifying from there. This is really just 4a over 2a squared, which would reduce to 2 over a if I'm using my exponent rules. So it's really not as bad as it looks. When it's in this complex fraction format, it's very confusing, it's complicated. So we go through these steps to make it simpler, make it a lot easier for us to actually go through and simplify. So let's look at one where we don't just have monomials here. Okay, so again, I have my numerator and my denominator. I'm going to change this to a division problem, meaning I'm going to write it out with an actual divides by symbol. Once I have that, I'm going to change it to a multiplication problem by multiplying by the reciprocal. And then at this point, I want to see if I can do some factoring. Now, I notice in my denominator here that this is a difference of squares. So I'm going to rewrite this so that it's k minus 1 over k times k squared over k plus 1 times k minus 1. So now it's a lot easier to see that these k minus 1s are going to cancel. I can also reduce this k squared over k. I'll do that in the next step though. So we have k squared over k times k plus 1. And then my k squared over k really reduces to just k. And all that's left in the denominator here is the k plus 1. So there we go. Now this one, what I want you to be careful of here is that, remember, this is the fraction bar that separates the numerator from the denominator. So in our denominator, we don't have a fraction, but for the purpose of keeping this simple so that it follows the same process we've been doing, let's just make this a fraction and put it over 1. So now what I have is I really have 15 minus 15r divided by 15r squared divided by 12r minus 12 over 1. And the reason I put the 1 here is because I'm going to change this to a multiplication problem, which means the reciprocal of that piece becomes 1 over 12r minus 12. So now I can go through and I can factor out some GCFs here. Let's see, let's pause real quick. I didn't notice that these were out of order. So instead of 15 minus 15r, let's make that negative 15r plus 15. That'll make this simpler. So let's change this real quick. So now my GCF is really going to be a negative 15, which leaves me with an r minus 1 over 15r squared times 1. And then I can factor out a GCF of 12, which leaves me with r minus 1. So a few things to cancel. Okay, these are 1s. I can also cancel out these 15s. Now keep in mind that the negative is still here. So let's rewrite it. We have a negative 1 in the numerator now. And then in our denominator, all that's left is a 12r squared. And that's going to be our final answer. There's no other simplifying or reducing that we can do. Now, this is the first example we've seen where the numerator and the denominator are not made up of a single fraction. Okay, my numerator is two separate fractions that are being subtracted. My denominator is good to go. Okay, that's a single fraction down there, but we need to focus on getting that numerator written so that it's a single fraction. So let's think about how we can do that. We can just kind of do it off to the side here. If I have x minus 3, or I'm sorry, x divided by 3 minus 3 over x, that means that this fraction needs multiplied by the 3. This fraction needs multiplied by the x. So now we get x squared over 3x minus 9 over 3x, which is going to turn into x squared minus 9 all over 3x. So this is what we're going to replace the numerator with here. So let's rewrite it. And now I can write this as a division problem. X squared minus 9 over 3x divided by x minus 3 over x. And then I can change it to a multiplication problem. And factor. So I've got a difference of squares up top here. So my x minus 3's are going to cancel. I can also cancel these x's out. And all that leaves me with now is an x plus 3 over 3. So at the very beginning, we just had that extra step of combining the numerator together to make a single fraction. So here's another case where we have to do that in the denominator this time. So I want you to pause the video and I want you to try to combine the things in the denominator together to make a single fraction, and then we'll jump back into it. All right, so off to the side here, I'm going to do the combining in the denominator. Think of 1 as 1 over 1. Think about it as a fraction. And if you think about it that way, really we just need to multiply. It's a little too small there. I need to multiply by w plus 2 in the numerator and the denominator. So that fraction becomes w plus 2 over w plus 2 minus w over w plus 2. So if we actually subtract, it becomes 2 over w plus 2. So that's what we're going to use for our denominator here. Okay, so let's rewrite it out. We really have w over w plus 2 divided by 2 over w plus 2. We can write it as a multiplication problem now. And what's going to happen here is the w plus 2's are going to cancel, and we're left with just w divided by 2. All right, here's our last problem. I want you guys to start this one. Actually, I want you to do this one start to finish on your own and give it a shot. All right, so for this one, the numerator and the denominator both need combined into a single fraction. Now, this one's not too bad because the numbers that I have here are just ones, which are going to make it a lot easier to be able to, combine, because I can think of 1 as 1 over 1, like we did in the previous problem. And if I need to get a common denominator of n, that means that really this is turning into m over n minus n over n all over m over n plus n over n. So my numerator is really just m minus n over n. My denominator is m plus n over n. And now I can change it to my division problem. Or if you want to just skip to multiplying by the reciprocal, that's okay too. And then we see that these n's are going to cancel. I cannot cancel the m minus n with the m plus n. So that's going to be our final answer. All right, everybody, I hope you found this video helpful. Let me know if you have any questions, and have a great day.